Hi, I'm Matej, a flight operations engineer working on the Columbus module of the International Space Station. On the ISS, we study all kinds of physical, medical and biological phenomena in the state of microgravity, not only to advance space exploration, but also to improve life on Earth. I'm tackling an exciting challenge, testing how an inhaler can work in space. My mission? To make space travel more inclusive so asthma doesn't stand in the way of future astronauts. Join me as I embark on my first parabolic flight and put my own experiment to the test to see if this small device could make a big difference for space exploration. Okay, first of all, let's talk about what a parabolic flight is using this highly advanced paper plane model. So a parabola is just a curve that resembles an upside-down U, and a parabolic flight is a flight with a slightly modified plane that follows a trajectory like this. So first climbing up and then flying straight down. The reason the plane follows this trajectory is that we need to somehow induce a free fall. The state of microgravity is basically a state of weightlessness, and we can achieve this by basically putting something in a state of free fall. Now a little bit about the experiment itself. So I wanted to study the flow of particles. To be specific, a flow of particles from an asthma inhaler like this one. Maybe you know this from everyday life. It's a very common medical device. If you or someone you know has asthma, you might see them using this quite often. It's pretty simple. You just press this little container at the top and a stream of particles comes flowing out. And what we want to study is how the absence of gravity is going to change the flow of these particles. So here on Earth in 1G, in this room, whenever I press this, these particles, due to being heavier than air, will start flowing eventually downwards when all the other forces stop acting on them. In microgravity, this will likely differ in some way. Of course, we can't just introduce this aerosol into the open cabin of the airplane. We need some sort of a device, and we are building an experiment, or actually have built an experiment, that is replicating a tiny bit of the human respiratory system. Once again, I have a piece of a medical device here. This is from an oxygen mask, and you can see it's kind of a ridged tube that actually replicates pretty faithfully the trachea you have in your upper respiratory system. So this is our tiny bit of the human respiratory system in which we will be testing the flow of these particles. I have yet again another medical device. This is a bag valve mask, again a very standard thing you might see in a hospital or in an ambulance. We will be using this as a kind of a lung surrogate. So instead of pushing air out, we'll be using the inflation of this to suck the air in. Now, to drag the air through this into this, we also want to measure something. So we have optical sensors, we have some other sensors that will help us measure two things, mainly the airflow, so how much air is flowing through this tube into this bag. And we also have another sensor that is then measuring with a laser the actual number of particles that come from this inhaler into the whole system and travel through the tube into the bag and then eventually out into the cabin. If you look at the profiles of astronauts from across the decades, the very first astronauts were all highly trained test pilots with amazing fitness and overall superhuman properties. However, over the years, this has changed. We now focus more on people who have certain expertise, so biologists, material scientists, anyone who has some sort of scientific background or engineering background. Therefore, knowing how to mitigate different medical conditions, such as asthma, will become more and more important, both for professional astronauts, but maybe also for space tourists that might emerge more commonly in the future. I'll be flying to the US in a couple days with all of this gear, and yeah, I'll be meeting my colleague Florence, who is also flying with the same organization. However, she will be running her own experiments as a biologist, so she will not be helping me with this particular experiment, but I'm interested to compare the results and also the feelings and the adaptation to the microgravity we're going to experience. So yeah, let's go. So today we're doing the first ground day. It's basically checking out all the experiments, making sure everything's compliant with the requirements and the regulations that we have to follow. My first task will be to actually put together all the parts that I've brought with myself and build the experiment so that it can be assessed by the team. And yeah, after that we'll install it into the plane. So the experiment is mostly assembled. It looks like this. Now I just have to see what the review says and how that's gonna end up. It's just before midnight and I'm back in the hotel room. It's been a long day at the hangar, assembling and testing the experiment, especially for the readiness review that the Zero-G company does to ensure that everything is as it should be and everything's safe. The experiment has passed the review with some small actions, mostly just taking care of some sharp, pointy bits that need to be covered up with tape to make sure it's not dangerous, nobody gets injured. And I have to say, seeing the plane for the first time today in the morning in person has made the whole thing 1,000 times more real. Just the realization that this is actually happening. So yeah, tomorrow is the big day, and yeah, after days and weeks of testing and building and assembling and disassembling and retesting, I actually get to fly this experiment, collect some data, and I hope everything goes well as it has up until now, and I hope we get some good data from this flight. So I'm really excited. And I hope everything goes well tomorrow. So we just finished working on our flight suits, finished putting on the patches. I've got the SGAC patch here, it's the organization through which we're flying. The Aurelia patch over here is the organization that's actually running the flight for us. We've got some flags as well here, and as you can see, both of our name tags, yeah, they're upside down. This is apparently a tradition that when you're flying a parabolic flight for the first time, you wear it like this, and only after you come back from your first microgravity experience on a plane like this, you turn it the right way up. So yeah, we have our boarding passes, and we're ready for this flight.
congratulations. You are now weightless certified. You are among the ranks of a very select group of people, including astronauts, who can actually say they've been weightless in zero gravity. Congratulations. Thank you so much, John. And this is for you. Thank you. Absolutely.
So here we are again back in the hangar just after the flight. As you can see, the name tag is now the right way up since the flight is officially completed. Yeah, it's a bit difficult to describe the whole experience. I'm still processing it. It's really unlike anything else I've done so far. But yeah, it went really smoothly. The hypergravity, the 2Gs, flew seamlessly into the 0Gs, into the microgravity where we floated around. It was surprisingly smooth and not unpleasant. I thought it's going to be more intense, but yeah, that's how it turned out. And yeah, now basically the time is to deinstall the experiment from the plane so it can be used for the next flight. And after that, for me, the next task would be to go into the electronics and see what data we collected, see if we have some meaningful results. So here we are back in Europe after the flight. It's been a couple days and I've had some chance to process not only the data but also the feelings and the overall impression from the flight. I think the most surprising part for me was the fact how easy it was to adapt to the state of microgravity. I expected it to be a bit more jarring, a bit more sudden, but once the pull or the 1G goes away, it felt very natural and seamless to suddenly go into this free floating mode and feel unrestrained. The whole experience is, of course, very intense and it's hard to describe. It's something I'll be chasing for a while and I would definitely like to experience again. It's impossible to describe in words, I think, since it's taking away a really core element of how we exist on this planet. So, as I said, I had a chance to look at the data as well. So far, the results look interesting. I couldn't resist to try to plot the individual particle measures, and it seems like there is some sort of an effect. Can't really say for sure what we're looking at, but from the graph, it seems like the particles flow a bit more easily in the weightlessness, which kind of makes sense intuitively, but we'll have to wait for a proper statistical analysis before we can make some solid conclusions here. I know it's a very ambitious goal, but if we manage to show that asthma is not a disqualifying factor for future astronauts, and if this project can contribute to that even with a teeny tiny sliver, then I think it's been all worth it. So let's hope we can at least start this conversation and show with this data that something can be done in this direction. And on top of that, if we manage to make life on Earth even a little bit better based on our findings, be it improved medication or better medicine delivery with aerosols, then I would be super happy. Then we would have achieved everything we set out to do with this project. So yeah, that's it from this iteration of the project. Thanks for joining me on this journey and hopefully see you at the next one.